Do you feel that? The moment you step into the forest here on Christmas Island, you catch this strange, sharp smell, like rotting fish left in the heat. But there's no garbage nearby. The smell comes from millions of dead crabs. Since the 1990s, yellow crazy ants have wiped out an estimated 40 million of the island's famous red crabs, leaving parts of the forest covered in torn shells and empty silence. Scientists needed something drastic to stop it. Their answer? Millions of parasitic wasps. The island where the forest started dying. Most islands are known for beaches or volcanoes, but Christmas Island became famous for something far stranger.
Now, hundreds of millions of red crabs crawl from the heart of Australia's Christmas Island to the ocean in an annual migration.
Every year, more than 100 million red crabs emerge from the rainforest at almost the exact same time and begin marching toward the sea. The ground literally turns red. Roads disappear beneath moving shells. Some people say it looks less like nature and more like a biblical plague moving across the island. And the craziest part is that these crabs are not just animals living on the island. They practically run the island itself. Scientists discovered that the red crabs act like the island's cleanup crew. They eat fallen leaves before they rot, recycle nutrients back into the soil, control plant growth, and stop the rainforest floor from turning into a tangled mess of weeds. Some ecologists even describe them as ecosystem engineers, because almost everything in the forest depends on them doing their job. But then came the ants. Nobody knows exactly how yellow crazy ants first arrived. One theory says they came hidden inside cargo shipments during the early 20th century. Another suggests they traveled through military supplies during World War II. Either way, once they reached the island, things escalated unbelievably fast. Unlike ordinary ants, yellow crazy ants do not always fight each other. Separate colonies can merge into giant super colonies, meaning billions of ants cooperate like one enormous organism. Scientists walking through some areas reportedly counted more than 1,000 ants in just 10 square feet of forest, and they attack in horrifying ways. Instead of biting large enemies to death, the ants spray concentrated formic acid directly into their victims' eyes. Crabs stumble blindly while waves of ants swarm over their bodies. Researchers found piles of dead crabs near invaded zones, many dying within 24 hours after exposure. One terrifying fun fact is that the ants became so numerous in some regions that they started climbing trees in black moving streams, coating branches so heavily that workers said it looked like the bark itself was moving, and then the forest began changing. Without enough crabs clearing leaves, the jungle floor thickened with weeds and seedlings. Humidity shifted, mold spread across trees. Invasive snails appeared in greater numbers. Scientists realized the island was slowly transforming into a completely different ecosystem. That's when conservationists decided to try something risky enough to terrify even other scientists. They planned to unleash tiny parasitic assassins into the middle of the war. The night the ants attacked the sky. What shocked scientists even more than the dying crabs was what started happening above the forest floor. The ants didn't just conquer the ground, they moved into the trees. In heavily infested zones, yellow crazy ants began farming scale insects high in the canopy, protecting them like livestock in exchange for sugary honeydew. Entire branches became coated in ants. Rangers reported that when they shook certain trees, ants would rain down in waves. And that's when birds began suffering. Christmas Island is home to rare seabirds and forest species found nowhere else, including the Abbott's booby and the Christmas Island frigate bird.
It's probably another side to Christmas Island. It's just awesome. These guys are actually quite unique.
These birds evolved without land predators. Many nest low or on exposed branches, completely unprepared for a ground-based insect army that could climb. Researchers documented ants swarming into nests, spraying acid into the eyes of hatchlings. Chicks too young to fly were left blinded or chemically burned. In some invaded sections, nesting success rates dropped sharply, and certain forest areas reportedly fell eerily silent. One field worker described stepping into a super colony zone at dusk and hearing almost nothing. No rustling lizards, no chirping frogs, no insect chorus. Just the faint crackling sound of ants moving through dry leaves. There were even theories circulating among conservationists that the ants might be altering the island's microclimate indirectly. With crabs gone and undergrowth exploding, thicker vegetation changed airflow patterns near the ground. Some researchers speculated this could affect soil moisture retention and fungal growth cycles in ways not yet fully measured. Another unsettling observation involved electrical infrastructure. In multiple tropical regions worldwide, yellow crazy ants have been known to swarm into power boxes and short-circuit systems. While not as widely reported on Christmas Island, scientists quietly monitored whether super colonies could eventually disrupt communication or park facilities if populations spiked again. The super colony that behaved like a single brain. One of the most disturbing discoveries scientists made wasn't just how many ants were on the island. It was how they behaved. Yellow crazy ants don't always operate like normal ant colonies. In many invaded regions, including parts of Christmas Island, researchers found that separate nests were not fighting each other. Instead, they merged into enormous super colonies. Multiple queens coexisted peacefully. Workers from distant nests cooperated as if they belonged to one unified system. In laboratory aggression tests, ants taken from opposite sides of a super colony often refused to fight. That meant what looked like separate infestations were actually pieces of a single sprawling organism. Some ecologists began describing the phenomenon as a distributed brain. Billions of ants communicating chemically, adjusting foraging patterns, shifting defensive zones, and reinforcing food sources in near real time. When scale insect numbers rose in one patch of forest, ant density increased there within days. When bait was dropped, surrounding nests sometimes intensified activity as if responding collectively. Field crews documented foraging trails stretching more than 100 meters in continuous lines, thick enough that boots became coated in ants within seconds. In extreme zones, soil samples suggested underground nest densities so interwoven that researchers admitted they could not define clear colony boundaries at all. Here's the unsettling theory. Supercolonies may arise because invasive ants leave behind the genetic competitors that would normally trigger territorial fighting. Without natural rivals, their aggression shifts outward instead of inward. The result is a cooperative invasion machine with almost no internal resistance. There's also speculation that climate change could amplify this behavior. Warmer temperatures and shifting rainfall patterns might extend breeding seasons or improve honeydew production from scale insects, indirectly fueling further expansion. The tipping point scientists feared was already too late. Long before the wasps were released, some ecologists were quietly asking a darker question. What if even removing the ants wouldn't fix the island? On Christmas Island, the red crabs aren't just participants in the ecosystem, they are regulators. By consuming fallen leaves, thinning seedlings, and constantly turning the soil with their burrows, they prevent the rainforest floor from choking itself. In areas where crab numbers collapsed, researchers observed leaf litter building up in thick layers. Seedlings that would normally be eaten survived in dense clusters. Within a few seasons, entire sections of forest began looking structurally different. This shift triggered what scientists call a potential ecological phase transition. Once plant density crosses a certain threshold, light penetration changes, soil temperature alters, and humidity patterns shift. Fungi multiply differently. Some native plants lose their competitive edge. Invasive plants and species, including the giant African snail, gain new footholds. One conservation biologist described parts of ant-dominated forest as appearing lush but biologically simplified. More green, fewer species. There were even concerns that if crab populations fell below a critical mass, mating migrations could fail to sustain long-term recovery. Red crabs release their larvae into the ocean during tightly synchronized events tied to lunar cycles and rainfall. If too few adults migrate, the next generation shrinks dramatically. A few weak seasons in a row could push numbers into a downward spiral. That's why the surge in migration numbers after 2017 was so significant. Some estimates suggested adult participation rebounded toward 100 million individuals. It wasn't just a spectacle returning. It was a signal the ecosystem might still be salvageable. But the fear remains. If supercolonies rebuild faster than crab recovery, or if climate shifts tip humidity patterns further, the island could cross a point where balance cannot easily be restored. The acid that turned the island into a chemical battlefield. There's one part of this invasion that sounds almost exaggerated until you look at the chemistry.
One of the world's worst invasive ant species that can be a domestic nuisance, but yellow crazy ant is particularly prominent for its environmental impact.
Yellow crazy ants don't rely on strong jaws to overpower animals many times their size. Their real weapon is formic acid. When threatened, they lift their abdomens and spray a fine mist of acid forward like a chemical flamethrower. In concentrated swarms, that mist becomes a fog. Field researchers documented crabs stumbling after direct eye exposure. The acid interferes with vision, burns soft tissue, and triggers frantic disorientation. Once the crab loses coordination, thousands of ants overwhelm it. But here's the lesser-known concern. What happens when this acid accumulates? In supercolony zones, where ant density can exceed 1,000 individuals per 10 square feet, repeated spraying doesn't just affect animals. It hits the leaf litter, the soil surface, and nearby plant roots. While formic acid breaks down relatively quickly in open environments, the sheer volume released in concentrated outbreaks led some researchers to quietly monitor soil chemistry shifts. Preliminary observations suggested localized changes in pH around heavily infested burrows. While not enough to permanently acidify the rainforest, repeated chemical stress could alter microbial communities in the soil, the invisible bacteria and fungi that help plants absorb nutrients. There's also the impact on other invertebrates. Ground-dwelling beetles, spiders, and native ants, species that evolved without exposure to such overwhelming chemical warfare, decline sharply in supercolony zones. In some invaded patches, biodiversity surveys found dramatic drops in native arthropod abundance. In effect, the ants weren't just physically overrunning the island. They were chemically reshaping it. And this chemical dominance may partly explain why supercolonies create those eerily silent forest pockets described earlier. When predators, decomposers, and competitors vanish under sustained chemical pressure, ecological functions collapse in layers. It's easy to see ants as tiny. But when billions operate together, armed with acid and unified behavior, the forest stops being a habitat. It becomes a battlefield. The human island in the middle of an ecological war. Lost in the science and the spectacle is one simple fact. People live here. Christmas Island is home to a small but tight-knit community of just under 2,000 residents. For them, the crab migration isn't just a wildlife event, it's a seasonal reality. Roads close, traffic stops, volunteers patrol highways moving crabs off asphalt. Special crab bridges and underpasses were built so millions can cross safely. When the ants surged, locals noticed before headlines did. garden beds started moving. Electrical boxes occasionally filled with ants. Outdoor equipment became unusable in infested zones. In other tropical regions, yellow crazy ants have caused power failures by swarming inside circuitry. On Christmas Island, authorities monitored infrastructure carefully, aware that a super colony near utilities could trigger cascading issues. There was also economic anxiety. Tourism on the island revolves heavily around biodiversity: red crab migrations, rare seabirds, pristine rainforest. If crab numbers collapsed permanently, visitor numbers could drop. Fewer tourists would mean less funding for conservation, which in turn could weaken the very programs fighting the ants. Some islanders described walking through heavily infested forest patches where ants crawled up their legs within seconds. Protective gear became standard for field workers. Rangers conducting bait drops reportedly endured thousands of bites in a single shift. And then there's the psychological layer. Imagine living on a remote island known worldwide for a natural wonder, and watching that wonder shrink year after year. Residents spoke about quieter forests, fewer crabs crossing roads, the eerie feeling of stepping into areas that once teemed with life and now felt strangely empty. For many, the wasp release and subsequent rebound in crab migration numbers felt personal. When roads once again turned red with moving shells, it wasn't just an ecological indicator, it was relief. But locals also understand something outsiders often miss. Christmas Island is isolated. 52 square miles of steep cliffs, caves, dense canopy, and inaccessible terrain. If ants re-establish deep inside untouched valleys, eradication becomes nearly impossible. The island that became a global test case. What makes the battle on Christmas Island even more fascinating is that the world is watching it like an experiment. Yellow crazy ants have invaded regions across Africa, Southeast Asia, and the Pacific. In some places, they damage agriculture. In others, they threaten seabird colonies. But nowhere has the invasion been as visible or as ecologically dramatic as on this isolated island where one keystone species dominates the landscape. Because of that, Christmas Island has quietly become a live laboratory for invasive species science. Conservation agencies, universities, and biosecurity teams monitor data here to refine strategies that could be used globally. How fast do supercolonies rebound after chemical baiting? How long does biological control take to suppress a food source? What happens to forest structure when a keystone species declines and then rebounds? The release of the parasitic wasp was not just about saving crabs. It was about testing whether highly specialized biological control could work in a complex rainforest without triggering unintended consequences. If successful long-term, the model could reshape how scientists approach invasive insect management elsewhere. Instead of repeatedly poisoning invaders, which often creates cycles of collapse and rebound, targeting the ecological partnerships that sustain them might prove more sustainable. There's also a broader theory gaining traction. Islands may serve as early warning systems for mainland ecological crises. Because island ecosystems are simpler and more isolated, changes become visible faster. What happens here could mirror future invasive dynamics in continental forests under climate stress. The migration that shut down an island. There is one moment every year that proves whether the island is winning or losing. It happens after the first heavy rains of the wet season, usually around October or November, when humidity spikes and lunar cycles align. Almost overnight, tens of millions of red crabs leave their burrows and begin marching toward the coastline. At peak migration, estimates have placed participation anywhere from 40 million to nearly 100 million individuals in strong recovery years. Roads turn completely red. The island's main highway can become impassable. Authorities close entire routes. Temporary fences guide the crabs. Specially constructed crab bridges allow them to cross safely above traffic. From above, it looks unreal. A living river of armor-plated bodies flowing through rainforest and over asphalt. This migration isn't random chaos, it is synchronized breeding. Males arrive first, dig mating burrows near the shore, and wait. Females follow, mate, and later release fertilized eggs into the ocean during precise tidal windows linked to lunar phases. Timing is critical. If eggs enter the water too early or too late, survival rates plummet. Here's what makes this migration so scientifically significant. It acts as a population barometer. When supercolonies of yellow crazy ants peaked, observers reported noticeably thinner migration waves in certain years. Fewer bodies on the road meant fewer adults surviving inland. Because red crabs can live more than 20 years, declines may lag behind invasion peaks, but once adult mortality crosses a threshold, recovery becomes slow. After the biological control efforts began reducing scale insects and ant pressure in key zones, researchers recorded stronger migration numbers again. For conservation teams, this wasn't just a spectacle. It was data. It meant enough breeding adults were surviving long enough to sustain future generations. There's even a long-standing local belief that when the migration is massive, fishing conditions offshore improve, an old community observation tied to nutrient pulses from larvae entering coastal waters. If you enjoyed this video, make sure to subscribe, because some of the strangest and most terrifying battles happening on Earth are unfolding in places almost nobody talks about.